Now whenever we expand two brackets, something like this that we've seen previously, x plus 2 into x plus 3, which gave us the answer x squared plus 5x plus 6. We got something that looked very similar to this kind of setup. We had an x squared term, we had a number term at the end, and we had an x term in the middle. Second example we had the x minus 5 into x plus 7, and that gave us a final answer of x squared plus 2x minus 35. Again, a very similar looking kind of setup. It's worth thinking about where the numbers in these terms come from, however. The 6, if we were to focus on the 6 in particular, thinking about what happened when we did the expanding previously, or looking at the numbers that are in the bracket, there is a connection between the 6 and the numbers that are there in the bracket. You may, for example, notice that 6, if we were to take the number 2 and the number 3 and times them together, we would get the 6 at the end. So the 6 comes from doing the two numbers times together. Is that true in the second one? Well, let's have a look. We've got the 5 and the 7 gives us the 35. The minus also comes from the fact that it's a minus 5. But the 5 and the 7 will give us the 35. So that works as well. And then the question is there any link between the number in front of the x and the number in the brackets? Well, there should be. Thinking about what happened to get that 5 or that plus 5x and that plus 2x previously when we simplified, notice that 2 and 3, they both give us a certain number of x in the question. Then we simplified to give them to give 5x overall, minus 5 lots of x and plus 7 lots of x. They simplified to give us the plus 2 lots of x. So in fact, if we did 2 add 3, or we did the minus 5 add the 7, then we will get these here. So we could say, actually, it depends what order we think about them in, that term in the middle comes from either adding or subtracting. Remembering, of course, that adding and subtracting are just basically the same thing, just moving up and down a number line, adding from moving up, subtracting from moving down generally. Once we start to bring signs into it, it starts to get a little bit trickier than that. But the number at the end comes from timesing the two things in the brackets together, the two numbers, and the number in the middle comes from adding or subtracting them together, depending on what the signs are going to be. Now, why is that useful? Well, because if you could be asked to start here and expand to get to here, then it makes sense that you might also have to go the other way. You might also have to start with this form and go back to the previous form, go back to the bracketed form. Previously, when we've seen the opposite of expanding, we had another of our keywords, and that one's about to turn up now. You may be asked to start with one of those forms, the squared term, the number at the end, and the x in the middle, and you might be asked, for example, to factorize, a word we've seen before. If expanding was getting rid of the brackets, then factorising is putting them back in. You could be asked, for example, let's just pick a question, to factorise x squared minus x minus 20. Now looking at that, that is one of these type of things, where we have got a squared term at the beginning, a number term at the end, and an x term in the middle. It is one of these type of equations. In fact, any type of equation like this has a particular name. Any equation where we have a squared term at the beginning, any equation with a squared term in, but generally they will look something like this, but any equation with a squared term in is referred to as a quadratic. Thinking about that word quad, like a quadrilateral perhaps, a square for example, quadratic links with this idea of being a squared term. So a quadratic is an equation with a squared term in it, or an expression, in fact, an equation or expression with a squared term in it. Like, for example, x squared minus x minus 20. Like, for example, x squared plus 5x plus 6. And the other ones that we saw in the expanding video. Now if we head back to this, and the question, factorise x squared minus x minus 20. Because we recognise that form, we know sort of what the answer is going to look like. The answer is going to look like this. And we know the answer is going to have an x here and an x here. And there is going to be a number here, and either an add or a take in the middle. If it looks like this, this is what the answer is going to look like. So we can start filling this in, and we can fill it in a little bit at a time. Now we notice from our pattern spotting that the numbers here have particular connections to what's going on up here. The numbers in these brackets will have to add or take to make the number in front of the x. There isn't a number in front of the x, but we know that we could add one in if we wanted. We could, if we found it helpful, add in the number 1 there. You don't have to. If that's more confusing to put it in than to leave it out, then don't. But if you want to put it in, then you can. So we need two numbers that add or take to make the number 1, and in fact that times together to make 20. Now there are a lot of numbers in the world, a lot of pairs of numbers that could add or take to make 1. So we would be better starting with the 20 as our focus, because there are a limited number of whole numbers that will times together to make the number 20. If we think about all the pairs of numbers that times together to make the number 20, then we have got 1 and 20, 2 and 10, and 4 and 5, in either order. And they are the only whole numbers that could possibly times together to make the number 20. It will guaranteed be one of these pairs. We just need to work out which one. Now we can use a bit of clever thinking with this. We can look at these pairs and see if any of the pairs will either, in any order, add or take to get to the number in front of the x. The number in front of the x is 1. Is there any way that the numbers 1 and 20 can be used, adding or taking, to get to 1? No. Is there any way the numbers 2 and 10 can be used, adding or taking, to get to 1? No. Is there any way, hopefully there is, to use the numbers 4 and 5 to get to 1? Well, yes, because 4 and 5 are 1 apart. So we can use the 4 and the 5, thinking carefully about the signs perhaps, but we can use the 4 and the 5 to reach that number in front of the x, that number 1. So we can use 4 and 5. I'm going to put 4 in the first bracket, I'm going to put 5 in the second one. It doesn't matter which way around you put them. As long as the signs match up with the numbers, I could put the 5 in the first bracket, the 4 in the second one. It makes absolutely no difference at all. So there are our numbers. Now we just need to work out the signs. There are 4 possible options for signs. They could both be plus, they could both be minus, or one could be plus and one could be minus in either order. We could have a plus then a minus, or a minus then a plus. We need to work out which one it's going to be. Now we could do a little bit of guessing, pick one, try it, see if it works, or we could think carefully. We could think about what numbers these will have to be to reach the exact number that's in front of here. Because the exact number that's in front of here is not 1, but in fact minus 1. So we have to think about how we can use the numbers 4 and 5 to reach minus 1. With a little bit of thinking, we might hopefully realise that if we started with plus 4 and then we took away 5, we would reach minus 1. Number plus 4 or 4, depending on your preference, will take us to minus 1 if we do 4 minus 5. So we could start with plus 4 and minus 5. And what we've done is we've started with something that looks like this expanded form, and then we've factorised it back into 2 brackets. The 4 and the 5 do indeed multiply to give us the 20, and if we think about the signs this time, plus 4 and the minus 5 will give us the minus 20, because the minus 5 will give us 1 minus 1 change of direction, minus 20, and plus 4 take away 5 will give us a minus 1 lot of x. So So the same question again, factorise, we'll have two brackets and we'll see where we get to. And this time we're going to factorise the expression x squared minus 8x plus 12. Now looking at that, that is this classic look, the squared term at the front, the number at the end and the x term in the middle. Fairly normal looking quadratic remembering any equation or expression that's got an x squared in it. If it looks like this, just like the other ones have, it's going to have these two brackets in there. So we can set up our blank answer ready, two empty brackets with an x in each. There's then going to be a number here, and a sign in the middle of each. We just need to work out what numbers are going to be here and which signs. To do that, we're going to think about how the numbers work to give us the numbers here. We are looking for two numbers that times together to give us the 12 and add or subtract to give us the 8. We're going to think about the 12 first, and we're going to first of all think about all the pairs of numbers that can multiply together to give us 12 in either order. We have got 1 and 12, we have got 2 and 6, and we have got 3 and 4. They are the only pairs of numbers that could possibly work. We're going to go through each one and we're going to see which ones can be used to make 8. 1 and 12, if we're thinking about adding or taking, is there any way that we could ever use 1 and 12 to get to 8? No, so we can discount that one. 3 and 4, is there any way we can ever use 3 and 4, adding or taking, to get to 8? No, so we can discount that one. Well, hopefully the 2 and the 6 will work. 2 and 6, can we reach 8 from 2 and 6? Yes, we can, because adding them together would give us an 8. So we can use 2 and we can use 6. I'm going to put 2 in the first bracket, 6 in the second, but remember, it doesn't matter which order we put them in, as long as the signs go in the right place later. It doesn't matter which way round the actual brackets are. So we're using 2 and 6. So we now need to think about how we can use the 2 and the 6 to reach the 8. At this point, we're going to notice that it's not actually an 8, but it is in fact a minus 8. We're going to think about how we can use 2 and 6 to reach minus 8. Well, the only way we can do that, the signs it will have to be, we will have to have minus 2, and then we're going down 6. So minus 2, subtract the 6. Meaning they're both minus and minus. And there is our final answer. X squared minus 8x plus 12 factorises to x minus 2 in the first bracket and x minus 6 in the second. Now bear in mind this method of factorising we are only going to do for any quadratic that looks like the ones we've seen. So we've got an x squared term at the front, a number term at the end and an x term in the middle. Anything that looks any different than that is not going to be this double bracket setup. But if it does look like that, it is going to be a double bracket setup. So, one final question then, factorise, same kind of question as before, and then 2x squared plus 9x minus 5. Now okay, we've got a 2x squared this time rather than just a single x squared, but this is still one of those types of quadratics where we've got the x squared term at the beginning, the number term at the end, and the x term in the middle. So it is going to be a double bracket setup. And we are fully expecting to have an x and an x here. Perfectly fine. We've seen this before, it's not that alien to us. We looked at it when we did the expanding two brackets thing. There's going to be a number here and a number here, plus a sign in the middle. The two numbers here are going to times together to make the 5 and add together to make the 9. Or subtract to make the 9, of course. Now, we can think about the 5 first of all, because that will help us narrow it down. What pairs of numbers can we use to multiply together to get 5? Well, there's 1 and 5, and actually that's the only option. We have to use the 1 and the 5. But is there any chance of using 1 and 5 to ever get to 9? Well, no, there isn't. We could reach 6, we could reach 4, and we could reach minus 4 and minus 6 if we wanted, but we're never going to reach 9. Or are we? Because there's something we've forgotten. If we have an x here and an x here, that's just going to give us a single x squared term when we expand. Think back to the expanding. When we reached a quadratic that looked like one of these as the answer for one of our expanding questions in the expanding two brackets video, we had something slightly different in the brackets. That 2 has to come from somewhere. So in fact, one of these brackets, doesn't matter which one, is going to have a 2x in it. So that when we have a 2x and an x that are multiplied together, we get the 2x squared. Why is that particularly important? Well, it's important here to get the 2x squared, but it's also important because it means we can now use the 5. Because think about it. Whichever number we put in here, when we split these brackets to expand them, if we were going to, the 2x would multiply by the x here and give us the 2x squared. The 2x would also multiply by this number and double it in size, which means we can use these to get to 9 if we double one of them. Because it would be 2x times whichever one was in here, either the 1 or the 5. So, look at these two numbers again, the 1 and the 5. Is there a way to get to 9 if we double one of them? Yes, there is. Because if we double the 5, we'll get to 10, and then we'll be using 1 and 10, which we can use to get to 9. Which means we're going to have to put the 5 in here. At the end of the question, after we've filled in the rest of this, I will expand this one as two brackets like we did before to prove that it gets to the 2x squared plus 9x minus 5. For now, just take it as given that we end up doubling one of the numbers, and I will show you why after this question. The 1 and the 5. We now need to think about the signs. We've put the 5 in here so it can be doubled with the 2x, and we've put the 1 in here because it has to go in the other bracket. In this case, the order did matter, notice, because we have to put the 5 here to be doubled with the 2x. Let's think about the signs now. Well, we need to reach a minus 5, and we need to use 10 and 1 to get to 9. Well, the only way to do that would be to have it being a plus 10 and a minus 1. So we need to have a plus on the 5 to give us the plus 10 when it doubles, and the minus on the 1 to give us that take away 1 for plus 10 take away 1 to give us 9. So overall, that factorises 2x squared plus 9x minus 5 factorises to 2x minus 1 in the first bracket and x plus 5 in the second bracket. And if you want some justification, some proof as to why it doubles, well, you could think back to that example we did in the previous video, the expanding one, or we could just do it here. If we were expanding this, we're hopefully going to get back to the original, we'd be ripping the first bracket apart, so 2x and the minus 1. We'd move in the second bracket into place next to it, the x plus 5. So over here we'd have the 2x times the x would give us the 2x squared, and the 2x times the plus 5 would give us plus 10x. There is the doubling process at work. The minus 1 times the x will give us minus 1x, or minus x if you prefer, and the minus 1 times the 5 would give us minus 5. 2x squared plus 10x minus x minus 5. The plus 10x and the minus x are going to combine together to give us 2x squared plus 9x, and then the minus 5 unaffected at the end, which is what we expected to get, the same as at the start of the question. Meaning that overall, a final factorised answer would be 2x minus 1 in the first bracket and x plus 5 in the second.